In the vast expanse of the universe, stars are born, live out their lifetimes, and eventually die in spectacular fashion. Among these celestial events, one of the most captivating is the nova, a powerful explosion that can light up the night sky, revealing the hidden wonders of our cosmos. But what exactly happens during a nova? Join us on an enlightening journey to explore this extraordinary phenomenon, delving into the intricate processes, historical significance, and profound implications of these explosive events. At the heart of a nova event lies a binary star system, where two stars are intertwined in a delicate gravitational embrace. In most cases, one of these stars is a white dwarf, an incredibly dense remnant of a once massive star that has exhausted its nuclear fuel. The other star, typically a larger companion, could be a red giant or a main sequence star. This intricate relationship is pivotal, setting the stage for one of the most dramatic cosmic displays known to humanity. As the more massive companion star evolves and expands, it sheds its outer layers, which are drawn toward the white dwarf due to its intense gravitational pull. This mass transfer creates an accretion disk, a swirling disk of gas and dust that forms around the white dwarf. As material from the companion star accumulates, it is subjected to extreme pressure and temperature, akin to a pot of water heating on a stove. The process is slow yet relentless, building towards a moment of explosive transformation. When the temperature on the surface of the white dwarf reaches approximately 1 million degrees Celsius, hydrogen gas ignites in a runaway nuclear fusion reaction. In this critical moment, hydrogen atoms fuse to form helium, releasing a colossal amount of energy in the form of light and heat. This explosive event, known as a nova, represents a stunning spectacle, a stellar firework that can brighten by a factor of thousands, momentarily outshining entire galaxies and becoming visible even in daylight. In mere moments, the white dwarf illuminates its surroundings with blinding brilliance. This cataclysmic explosion ejects a significant portion of the accumulated material into space at staggering velocities, often exceeding 1,000 kilometers per second. The shockwaves generated by the explosion create a dazzling display of light and energy, and the nova can remain visible for weeks to months before gradually fading. But beyond the immediate spectacle, this event offers invaluable data for astronomers studying stellar dynamics and evolution. After the initial explosion, the nova enters a fading phase, gradually losing its brilliance as the expelled material disperses into the surrounding space. This ejected matter, rich in essential elements like carbon, nitrogen, and oxygen, plays a crucial role in the cosmic recycling process. Over time, it enriches the interstellar medium, an essential component for the formation of new stars and planets. Each nova acts as a cosmic forger, creating elements vital for life as we know it and contributing to the ongoing evolution of the universe. Novas have been documented throughout human history, each one leaving an indelible mark on our understanding of the universe. Ancient civilizations often viewed these bright events as omens or divine signs. For instance, the supernova SN 1054, which led to the formation of the Crab Nebula, was recorded by Chinese astronomers, while the explosion of Nova Cygni 1975 captivated the scientific community and the public alike. These historical occurrences not only broaden our knowledge of the cosmos, but also highlight our long-standing fascination with celestial phenomena and our efforts to decipher the mysteries of the night sky. The cultural impact of novae is profound. Throughout history, various cultures have interpreted these cosmic events through their own lenses. In some traditions, Novas were seen as heralds of change, signaling important transitions in society or the natural world. For example, the Aztecs regarded bright stars and comets as powerful omens, while European astronomers in the Middle Ages often linked novae to divine intervention. These interpretations reflect humanity's deep connection to the cosmos and our quest for meaning in the grand narrative of existence. Today, researchers utilize advanced telescopes and observatories, such as the Hubble Space Telescope, the Keck Observatory, and upcoming projects like the James Webb Space Telescope, to monitor novae in real time. These instruments capture light curves and spectral data that provide insight into these explosive events. By analyzing this data, scientists can decipher the intricate processes leading to a nova, gaining a clearer picture of the conditions that foster such dramatic transformations in stars. This research enhances our understanding of binary star systems, revealing how mass transfer and gravitational interactions can lead to explosive phenomena. In the grand tapestry of the universe, novas play a vital role in the life cycle of stars. They are part of a continuum where stars are born, live, and die, contributing to the intricate web of cosmic evolution. These explosive events remind us of the dynamic nature of the cosmos, where creation and destruction are intimately intertwined. Each nova serves as a testament to the power of stellar processes, offering us a glimpse into the past and future of stellar formation and decay. The materials expelled by novae, rich in essential elements like carbon, nitrogen, and oxygen, play a pivotal role in the formation of new stars and planets. This process is fundamental to the evolution of galaxies and the emergence of new solar systems. Without novae, the chemical diversity of the universe would be significantly diminished. This highlights how interconnected all matter is in the cosmos. Each nova is not merely a fleeting explosion, but a crucial contributor to the ongoing story of creation, influencing the very conditions necessary for life. As we look to the future, the study of novae promises to reveal even more about the universe. Upcoming missions and advancements in technology, such as gravitational wave observatories and space telescopes, will enhance our ability to observe these stellar events and better understand their implications for cosmic evolution. By continuing to study novae, we can uncover the mysteries of star formation, the behavior of binary systems, and the very origins of the elements that make up our world. The collaborative efforts of astronomers, physicists, and engineers across the globe are driving forward our understanding of the universe. With each nova we study, we not only deepen our knowledge of stellar life cycles, but also enhance our appreciation for the intricate design of the cosmos. Each discovery contributes to a larger narrative, a story of cosmic evolution that transcends time and space, linking us all in a shared journey of exploration. The life of a nova is a testament to the complexity and grandeur of the universe. Each explosion is not only a spectacular display of energy, but a reminder of the wonders that lie beyond our planet, urging us to explore further and seek to understand the cosmos that surrounds us. Ultimately, the story of a nova transcends its explosive nature. It embodies the interconnectedness of all things in the universe, a cosmic dance that continues to inspire our quest for knowledge. As we gaze into the night sky, we are reminded that we are part of a much larger cosmic narrative, one that invites us to look up, wonder, and explore the mysteries that await us among the stars.